All right, welcome back to our unit on matter. Today's topic is the periodic table of elements. Okay, so get your periodic table out if you haven't already done so. All right, so lesson 2 of 4, your objectives are as follows. Okay, you'll learn what the periodic table is and how it is arranged and organized. Okay, you'll know the difference between groups and periods in the periodic table. Okay, you'll understand the reactivity and properties of the different groups on the periodic table. And finally, hopefully you'll become familiar with the 7 naturally occurring diatomic molecules. Okay, feel free to pause this video anytime you feel necessary. Here we go. So, for your quick write, what are some elements on the periodic table you're familiar with or have heard of? Okay, why do you think the periodic table is organized the way it is? Take a look at it. Okay, and then how do you think the elements vary or change throughout the periodic table? Okay, and finally, what do you know about metals? If you can, try listing some physical properties of metals. Okay, feel free to pause this. I'm going to move on here. Okay, so the periodic table. In every chemistry room, you can expect to see a periodic table. The periodic table is made up of atomic symbols for each element. Okay, so for example, hydrogen here, the symbol is H to represent the element hydrogen. The element carbon is represented by a symbol C. Okay, it's also listed in an order of increasing atomic number. 1 for hydrogen, 2 for helium, 3 for lithium, 4 for beryllium, 5 for boron, 6 for carbon, and so on. Okay, so it is also arranged in vertical and horizontal columns. Okay. So, Mendeleev, a Russian scientist, arranged the elements by atomic number in 1869. He arranged it this way because he noticed similarities in the chemical properties in the way these elements behaved. Okay, for example, consider fluorine, chlorine, bromine, and iodine. Okay, over here on the far right. These elements are very similar in how they react and behave. Okay, and this is because they have a similar electron arrangement. They react and behave in a very similar fashion. Okay, so they're very similar. Okay, so what is the periodic table for your notes? Question on the left-hand side, answer on the right-hand side. Okay, go ahead and pause this while you write. I'm going to move on. Okay, so groups. Elements with similar chemical properties that lie in the same vertical column are called groups. Okay, groups are often referred to by the number over the column. So for example, we just talked about fluorine, chlorine, bromine, and iodine, okay? These elements make up group 17 if you look on your periodic table, okay? Well, groups are often referred to by the number over the column, all right? So we can see we start with 1 here all the way over to 18. So there are 18 groups in the periodic table. So you may also have noticed that there are horizontal rows on the periodic table. So we call these horizontal rows periods, okay? There are 7 periods in the periodic table. So what is the difference between groups and periods? Okay, go ahead and pause this while you write. Question on the left-hand side, answer on the right-hand side. Okay, I'm going to move on here. All right, so alkali metals. Let's look at the alkali metals here in group 1. So in group 1, we have the alkali metals. Okay, so group 1 alkali metals are elements such as lithium, sodium, potassium, okay, rubidium. These metals share similar chemical properties with each other. They behave in a very similar manner in how they react and combine with other elements. Okay, so they are also very reactive and are almost always combined and bonded with other elements. An example would be like sodium chloride in your salt. Sodium will never be found as pure sodium, okay, in nature. It's always bonded to and combined with other elements, okay? So the alkaline earth metals. Okay, in group 2, we have the alkaline earth metals. Okay, so group 2 alkaline earth metals include elements such as beryllium here, okay, magnesium, calcium, strontium, barium, okay. These metals, once again, share similar chemical properties, okay, because they're in the same group. Okay, the halogens, which we just talked about earlier. In group 17, we have the halogens. All right, so group 17 halogens include elements like fluorine, chlorine, bromine, iodine. Okay, many of these elements are gases or liquids at room temperatures. All right, so once again, these elements, because they're in the same group, share similar chemical properties. They behave and react, okay, in a similar manner. All right, so the noble gases over here in group 18 in the far right. Okay, well, group 18 noble gases include elements such as helium, neon, and argon. Okay, as their name implies, these elements are gases at room temperature. Okay, if you've ever seen a neon sign, well, those are made up of noble gases. Okay, noble gases do not react with other elements. Okay, they are atomic loners, if you will. Okay, they like to be by themselves. For example, if you have a helium balloon, okay, if you have a, a balloon of pure helium, okay, inside that balloon are just single helium atoms. Okay, that's because helium does not like to combine with other elements. Okay, it likes to be by itself. All right, transition metals. In groups 3 through 12, we have the transition metals. All right. So transition metals include many of the elements, okay, we are familiar with, such as nickel, iron, copper, gold, silver. All right. So for your notes, question on the left-hand side, answer here on the right-hand side. Make sure you mention and write down that these, okay, the group 1 alkali metals, that these metals are extremely reactive. Very important, okay? And on the far right-hand side, the noble gases are the exact opposite, okay? Make sure you write down that they are non-reactive, or we say inert, okay, and exist in nature as single atoms, okay? Very important, all right? So go ahead and pause this while you write. I'm going to move on. All right, metals, semimetals, and nonmetals. Okay, so the periodic table is also classified into 3 basic different types of substances. Okay, so we have metals, okay, semimetals, and nonmetals. Okay, that includes hydrogen up here. So the metals, well, just looking at it, okay, the periodic table, you can see that most of the periodic table is made up of metals. Okay, metals conduct electricity. Okay, they are malleable, which means they can be hammered and flattened. Okay, they are ductile, which means they can be stretched and pulled into wires. Okay, and they're lustrous and shiny. Okay, these physical properties make metals very useful in our society. Okay, so what are metals? Question on the left-hand side. Answer here goes on the right-hand side. Please draw this for your notes. Okay, I'm going to move on. All right, so semimetals. All right, well, the semimetals. Okay, the elements that divide the metals and nonmetals are what we call semimetals. Okay, well, these elements are also called metalloids. All right, just another name for semimetals. They have properties of both metals and nonmetals, so they're kind of like metals, but they're kind of like nonmetals. All right, so examples are like silicon, which hopefully you've heard of, used in computers. Okay, and germanium here in arsenic. Okay, so what are semimetals? All right. So question on the left-hand side, answer on the right-hand side. Okay, make sure you're writing the examples down. Please draw. Go ahead and pause this while you write. I'm going to move on. Okay, so nonmetals. The good old nonmetals on the far right side of the periodic table. Okay, well, nonmetals are just like they sound. They're elements that lack properties of metals. Okay, they don't conduct electricity. Okay, and they are brittle and dull in color. Okay. So they also show a lot of variation than metals do. Okay, so examples would include oxygen gas, chlorine gas, bromine, sulfur, a yellow solid, right? It's brittle, you can break it. Okay, carbon, your pencils, lead is really carbon, graphite. Okay, it's brittle, it breaks, right? And it's kind of dull in color. So, and then like I said, there's a lot of variation in the nonmetals, like oxygen, it's a gas, okay? Chlorine, a gas, okay? So they're a lot different. The nonmetals are a lot different than metals, okay? So, what are nonmetals? Okay, question on the left-hand side, answer on the right-hand side. Okay, please draw this for your notes. Okay, go ahead and pause this while you write. I'm going to move on. All right, so the natural states of the elements. Almost done here. Question on the left-hand side here. When we get there, answer on the right. So elements on the periodic table are different in how they behave and react with other elements. Okay, so hopefully you've learned that already. So some elements, such as sodium, are very reactive and readily combine and bond with other elements. They don't like to be alone. Okay, they instantly hook up with elements to form a bond. Okay, well, other elements like gold and platinum and helium, okay, are non-reactive, or we say inert, and do not like to bond with other elements. Okay, well, it's these chemical properties that make metals like gold and platinum highly valuable and sought after. Okay, so the noble gases. If you remember, noble gases such as helium, neon, argon are non-reactive and exist in nature as single atoms. Okay, we say these noble gases are monoatomic. They're individual single atoms, okay, or lone atoms, if you will, that are never bonded or combined with other elements. Okay, so for example, a helium balloon, like I talked about earlier, it's just single helium atoms. Okay, the balloon is filled with lone helium atoms. Okay, no other element is bonded to it or combined with it. Okay, so diatomic molecules. Some elements are found in their natural states as diatomic molecules. Okay, a diatomic molecule is a molecule made up of two atoms bonded together. Very important here. Okay, so for example, consider a balloon just with air. Okay, this time air is a mixture of 79% nitrogen gas and 20% oxygen and 1% argon gas. Okay, well, N2 and O2 here are diatomic molecules. So when you're breathing in air, you're basically breathing in diatomic molecules of oxygen and nitrogen. Notice two atoms, diatomic, O2, two atoms here, N2, two atoms. Okay, argon though is monoatomic here. Okay, so other diatomic molecules at room temperature include the following. So we have H2, okay? H2 is a gas. N2, O2, F2, and Cl2. So in nature, these elements, okay, are always in a diatomic state, which means they're bonded with, there's two atoms bonded to each other. Okay, so, but Br2 is a liquid, okay, at room temperature, but it's still diatomic. And then we have a solid, I2, okay, at room temperature. Notice it's still diatomic. So we have all of these elements like to form diatomic molecules, two atoms bonded together here, okay? So what are the 7 naturally occurring diatomic molecules for your notes? Last one for today. Question on the left-hand side, answer on the right-hand side, okay? Go ahead and pause this while you write. I'm going to move on. Okay, so you made it. Summary. You can always write your own. All right, so compare and contrast periods and groups. And then in which group can each of the following be found? Compare and contrast the reactivity of alkali metals and the noble gases. Which group is more reactive? Which group is less reactive? Inert, we say. Okay, and explain the difference between diatomic molecules and monoatomic atoms. How many diatomic molecules exist in nature? Okay, and then finally here, describe the physical properties for each of the following: nonmetals, metals, and semimetals. Go ahead and pause this while you finish your summary. Okay, we'll see you next time.